There's a quiet revolution happening right now on America's factory floors. It's this massive technological shift that's basically rewiring how we make everything, and it's all being powered by a brand new digital backbone. Now, if you're in manufacturing, these words probably give you a headache. Production delays, quality issues, downtime, these are the daily fires that can absolutely derail production and just crush your profit margins. They're the things that keep engineers and managers up at night.
So it really makes you wonder, right? With all the incredible technology we have, why are these problems still so darn hard to solve? Why don't the quick fixes ever seem to stick? Well, the answer is usually hidden just beneath the surface, in the complexity of the factory floor itself.
And that brings us to our first section. To really get a handle on these issues, we've got to look past the obvious. These aren't just one-off failures. They're actually symptoms of much deeper, systemic challenges.
This right here, this gets to the absolute heart of it. You can't just put a bandage on one part of the system and expect everything to be okay. The real solutions, the ones that last, require you to understand how everything is connected, the materials, the tools, the operations, and all the data that's flowing through it.
So if the problems are baked into the system, the solution has to be too. And this, my friends, brings us to the core of this whole transformation: artificial intelligence and the rise of smart manufacturing.
Okay, so what exactly do we mean by smart manufacturing? It's more than just a buzzword, and it's definitely more than just a bunch of robots. Think of it like building an intelligent, connected ecosystem that uses data to make smarter decisions, to see failures before they happen, and ultimately to create a production process that's just way more resilient. You know what's fascinating here? It's that pretty much everyone agrees on this. It doesn't matter what their background is. Experts all say the same thing. For the U.S. to bring manufacturing back home and stay competitive, investing in AI and automation isn't just a nice-to-have. It is an absolute strategic necessity.
And the data? Well, it's pretty compelling. A 2023 report from Deloitte showed that AI-driven automation can cut operational costs by up to 30%. Think about that. For any manufacturer, that's a total game changer.
But it's not just about saving money either. That exact same report pointed to a potential productivity jump of up to 25%. So you get this incredible 1-2 punch: lower costs and higher productivity. Those are the twin engines driving the return of American manufacturing.
And let's be clear, this isn't just some theory in a report. The biggest companies in the world are pouring billions, with a B, into making this a reality. They are literally building the digital backbone for the next generation of American industry. Just look at this timeline. The last few years have seen this massive acceleration. We're talking titans like TSMC and GM dropping billions on brand new facilities. This isn't some slow trickle. It's a huge signal that the shift to smart manufacturing is happening right now, and it's happening at an incredible scale.
And the money is coming from all sides. You've got tech giants like NVIDIA and TSMC, and they're joining forces with automotive legends like GM and Ford. They are all investing heavily in building out these advanced manufacturing capabilities right here in the U.S.
Just to give you a sense of the sheer scale here, NVIDIA alone is investing up to $500 billion over 4 years to produce its AI supercomputers and chips in the United States. That is a monumental bet on the future of American tech.
And here's the real takeaway from all this. This is so much bigger than any one factory. This is about building the entire nation's digital backbone. By making the core components of AI right here at home, the U.S. is securing the very foundation for the future of smart manufacturing.
But all this incredible technology is really only half the story. Because with all this new tech, you create a new demand. A demand for a totally new kind of expert. A new class of engineer.
Let's just walk through a classic real-world example. Imagine you're in a factory and you suddenly see a spike in defective parts. Let's say it's these brackets. The bolt holes are just slightly off-center and it's creating a huge bottleneck down the assembly line.
Now, your first reaction might be to treat it as a simple quality control problem, right? Maybe add another inspection step. But is that really getting to the root of the problem?
Well, this is where that skilled engineer comes in. Instead of just adding a patch, they start digging deeper. And they might find that the problem isn't the process at all, but the tooling. The fixture that's holding the part in place is worn out, and that's causing that tiny but critical defect.
And this just perfectly highlights the value of human expertise. What looked like a quality problem was actually a tooling problem that was creating a massive production problem. See, the technology can spot the defect, but it takes a human engineer to connect all the dots and find the real source.
This quote really just says it all. You can have the most advanced, most expensive factory in the world, but without smart people who can ask the right questions and really understand the data, that technology is never going to live up to its full promise.
So, if this new class of engineer is the future, how do we create them? The answer, it turns out, lies in a totally new approach to education, one that's designed for this complex, data-rich world of manufacturing.
Educational programs, like the one at Michigan Tech, are tackling this head-on with frameworks like the 4 pillars of manufacturing. This makes sure engineers get expertise across the entire system, from the raw materials and tooling all the way to operations, and then how all of it connects to make a business competitive on the world stage.
And what's so powerful about this approach is how it translates directly to the factory floor. A course in Industry 4.0 that prepares engineers to lead these massive digital transformations. Operations management gives them the tools to solve bottlenecks. And statistical methods, that equips them to lead Six Sigma initiatives. That super disciplined, data-driven approach to wiping out defects. It's a direct bridge from the classroom to real-world impact.
This famous quote from W. Edwards Deming just sums it all up perfectly. A smart factory and a smart engineer, they don't just find mistakes, they prevent them by building quality into the system from the very beginning. It's all about being proactive, not reactive.
So the smart factory is where it all comes together. People, machines, and data. But right at the center of it all is the need for human leadership. The technology is here, the investment is flowing, the factories are being built. The only question left is, who's going to lead them? Will it be you?